So we are given the following problem, and the first question, and I believe this is for Newton's second. So the first question here would be that state Newton's second law of motion in words, and you are supposed to write it in words and not symbols. And this will read as follows. You say that when a non-zero net force is applied on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. This should be written word for word, and for that you get 2 marks. Question 1.2 says that we should draw a labeled free body diagram indicating all forces acting on the 4 kg block, and we will look at the 4 kg block. There it is. And this question is allocated 3 marks, so that means we need to draw 3 forces that are acting on the 4 kg block. So clearly we would have the FG going downwards. We have FG. We also have a tension going downwards there. The tension on the 4 kg, which is here at P, we call it tension 1. That will be tension 1 going downwards. And we have another tension here at point Q, which is called tension Q, not Q, but tension 2 going upwards. So we'll just finish off here by labeling tension 2. And these are the 3 forces, and this is how the marks would be allocated. Now for 1.3, calculating the magnitude of tension 1 in string P, which is this string here. That means I'll have to use a simultaneous equation in this one, and you can see by the mark allocation there. Now, the first thing that you are advised to do is to draw a free body diagram for both objects. In that way, it will assist you. And since the object is going in this direction, meaning it is going up, I am going to choose up as positive. And now since up is positive, that means now this side T2 would be positive, T1 would be negative, FG negative, and then T1 this side will also be negative. No, it has to be positive. It has to be positive because it is going up, and I am choosing up as positive. And then we also have FG, which is going to be negative here. We therefore apply Newton's second for both blocks, for the 4 kg as well as for the 15 kg block. Then we will look at all the forces that are causing this block to accelerate or decelerate. If you look at 4 kg, it's T2, T1, and FG. And for the 15 kg, it's only T1 as well as FG. Take note that T1 and the T1 on the 15 kg block as well as the T1 on the 4 kg block will not have the same sign, one being positive, the other one being negative. That is very important in our calculation, and you will see as I proceed. So now I'll just have to sum up all the forces and include the signs, the negative and the positive. That means it will be T2 plus negative T1 plus negative FG, which will all equal to MA. At the end, this will just be T2 minus T1, and we can change this one to be MG. Yeah. And now let us substitute. T2 is 280. So I will substitute 280 here. Then that's T1. And of course, my mass will be 4 kg, 9,8, 4A. So with my calculator, I check 4 multiplied by 9,8. This will give me 39,2. Then I will solve for 280 minus it's 280 minus 39,2. So I get a positive 240,8. Now I'll make T1 or negative T1 the subject of the formula. And after that, I can just divide by -1 so that my T is positive, which is the tension. I will therefore end up with T1 being equal to -4A plus 240,8, and that would be my equation 1. Now for the 15 kg block, we do the same. We apply Newton's second law, and obviously my T1 will be positive and my Fg will be negative. We therefore sum up the forces, and I will end up with T minus mg equals to ma, and I will proceed to make T the subject of the formula, and this is what I end up with. So now I can substitute and end up with an equation number 2. So since we are dealing with a 15 kg block, I will substitute 15 on the mass, and I will solve this, and then I'll end up with equation number 2. So when I punch 15 multiplied by 9,8 in the calculator, I end up with 147, and therefore this will be my equation 2. Now we know that this would be tension of the same rope, which is T1, and in that case, if T1 is the tension of the same rope, we know that, by the way, I'm supposed to say T1 here. Apologies. This is T1, not just T. So let me just label it as T1. So T1, which is the tension between block 4 and 15, would be equal because this is tension of the same rope. So T1 will equal to T1. And now we can substitute our equations and solve for the acceleration. So what I did, I substituted for T1. There is the equation. Oh, not that one. This one. Yes. And then for another T1, this would be my equation. So basically what is happening here, we are saying that the tension is equal for both because this is the tension of the same rope. That is the concept of equating the T1s on both objects. Now make sure the like terms are on the same side. Now I can solve for acceleration. Now I can therefore divide by 19 on both sides, and I will obtain my acceleration. The acceleration is going to equal to 4,94 meters per second square. Now this is not the end because the question asked us to calculate tension in T1. So I can use any of these equations, T1, to get tension 1, which is in string P. I will use equation number 2 since it is positive. I'll just use equation number 2 and see what my tension will be. In equation number 2, I therefore substitute the acceleration, and I'll put that in the calculator. So now if I put this in the calculator to solve for tension 1, that will be 221,1 newtons. And if I decided to use equation number 1, which is -4a plus 240,8, I will still get the same answer. So it will depend which answer you get or which equation you use. What matters is the answer will be the same.